Now we see the theorem. And the statement is that if f from a to r is a function and if c is a cluster point or limit point of a, then f can have only one limit at c. So simply, the meaning of this theorem is that if the limit of the function exists, it have only one limit. That means if limit of function fx when x approaches to c is equal to L something, that means if it exists, then it is unique. So how to show such kind of results? If whenever we have to show there is unique thing, so the idea is that consider two things and then show that the two things are not different, they are same. So to prove this, we consider, suppose L and L dash are limits of fx at point C. So we consider two limits, and what we wish to show, they are not distinct, they are same thing. So let limit of fx when x approaches to c is L. So what does it mean by the definition of epsilon delta definition of limit? So it means that for any epsilon greater than 0, there exists a delta greater than 0 such that modulus of fx minus L is less than epsilon when x is point of set A and it is distinct from C and lies in a delta neighborhood of point C, right? So this is by definition of limit. Now again, as we consider L and L dash are limits, so now I consider L dash as a limit of function. So again, by definition of limit, what I can have? By definition, for any epsilon greater than 0, there exists a delta greater than 0. So in both the cases, delta appearing. But as function f is defined on the same domain, right? The point x tends to a is in the same domain. So we should have the distinct neighborhood for the same point C. That means if it can be point C, it is a C minus delta, C minus C plus delta. So it will have some distance, and this can be the other C minus delta 2 and C plus delta 2. So let me call it as a delta 1, right? So that the two deltas should be differentiated separately. So for there exists some delta, so let me call it as delta 2, such that the difference fx minus L dash is less than epsilon when x is point from the set A and it is distinct from point C but lies in a delta 2 neighborhood, right? So this is by the definition we have considered the two limits. Now how to show this? And for simplicity, okay, later on we will change this thing. So now consider this difference of L and L dash. So I make some adjustment as L minus fx plus fx minus L dash. I have added and subtracted the thing fx. So it is equal to, I can write it as by the triangle inequality, it can be written as it is less equal L minus fx plus fx minus L dash, right? So modulus of a minus b is same as modulus of b minus a, because minus sign doesn't matter for the absolute value. So let me call this as equation 1 and this as equation 2. Okay. So, but equation 1 says that this thing L minus f is less than epsilon, right? So it is less than epsilon. Equation 2 says that fx minus L dash is less than epsilon. So what we wish to show, that means L minus L dash is equal to 2 times epsilon. So now consider for, so let me choose, if these are two different neighborhoods and I have to take common part of these two. So what I should do? So I should do. So what I want, this difference is very small. So for simplicity, I choose here it to be epsilon by 2 and this is also to be epsilon by 2. So then what happened? What I get? This quantity L minus L dash is strictly less than epsilon. And what? We have seen the result or property of real numbers that A is less than epsilon and epsilon is arbitrary. So it means that epsilon is arbitrary. It means that L minus L dash is 0. So L equal to L dash. So the limit we have considered L and L dash are not different, they are same things. Therefore we can say that if the limit of function exists, then it is unique. So if limit of f if exists, it is unique. Now let us see some examples on limits. So limit of k is equal to k, where f of x equal to k, a constant function. All of you know very well that limit of constant function is same, but we have to show it by the definition of limit. We have to show this thing, means by the definition of limit, what we have to show? We should show, we have to show for any epsilon greater than 0, there must exist a delta greater than 0 such that modulus of fx minus its limit is less than epsilon when x is point from a and 0 less than mod x minus c is less than delta. That means it means we have to find a delta, value of delta. So from this we know that the difference k minus k is definitely 0 and epsilon is positive. So for this case, for this example, we don't want any change. Therefore, for any epsilon greater than 0, if we choose, remember that we have to find value of delta in every example to show the existence of limit by the definition of limit. If we choose delta to be any positive real number, so the case will work, because the difference k minus k is directly 0, doesn't matter when x is point from a and 0 less than mod x minus c less than delta, and then therefore limit of the definition of limit holds. So limit of function k when k is constant is k. Right? We take the second example. Limit of x when x approaches to c is c. So we have to show limit of x is c. So by definition of limit, what we have to show? We have to show this thing. That means for any epsilon greater than 0, there exists a delta greater than 0 such that modulus of x minus c f of x minus its limit is less than epsilon when x is point of set A and 0 less than mod x minus c less than delta. Okay, so what we have to do? We have to find a value of delta. Now observe that our delta neighborhood is this thing, and as it is limit x approaches to c, it is limit of function x and it is c. So this term is repeating here. So what delta we should have? Here the statement shows that x minus c is strictly less than delta. Here what I want? I want this quantity to be less than delta, and epsilon is what? Epsilon is given. So what delta I should have? What delta we should choose? Therefore, for any epsilon greater than 0, if we choose this delta to be equal to epsilon, compare these two things. I want this quantity to be less than epsilon. Epsilon is positive real number. And what is this? X should belongs to a delta neighborhood. That means x minus c should be less than delta. This thing should be less than delta, and this thing, what I want it to be less than epsilon. So epsilon is given. What delta we should take? So we should take this delta to be equal to this epsilon. As epsilon is greater than 0, so delta will be greater than 0. Then this thing, modulus fx minus L is less than epsilon when x is point from A and 0 less than mod x minus c less than delta. So this is delta neighborhood, and what is its size? It is of radius epsilon. We have chosen delta to be equal to epsilon. So this is definition of limit which is satisfied, and therefore we can say that limit of function fx equal to x when x approaches to c is c. Right? The next thing, limit of x square when x approaches to c is definitely c square. All of you know very well. But we have to show this thing by the definition of limit. So it means what? By definition of limit, we have to show what we have to show? For any epsilon greater than 0, there must exist a positive delta, that means delta greater than 0, that satisfies what? Fx minus L, that means x square minus c square is less than epsilon when x belongs to a delta neighborhood of point C. That means we have to find such delta. So what delta we should take? So okay, this can be written as x square minus c square is equal to this can be factored x plus c into x minus c, and by using the property of absolute value, it can be written as x plus c into x minus c. Right? Observe that this thing is, we want x square minus c square to be less than epsilon, and here it is modulus of x minus c less than delta. So x minus c occurring in the factorization of this thing, and this is something else additional. So what we should do with that? Right. So therefore, if we consider this mod x minus c less than 1, then what can be modulus of x? Modulus of x, okay, then mod x plus then mod x will be mod x plus c, mod x minus c, yeah, then mod x is mod x minus c plus c, okay, then it will be less equal mod x minus c plus mod of c, so it will be less equal, this thing is strictly less than 1 plus mod c. So this is for mod of x, and what will be mod of x minus c? So by using triangle inequality, it will be modulus of x plus modulus of c. So use this thing, modulus of x is strictly less than 1 plus mod c, 1 plus mod c plus this thing mod c. So modulus of x minus c is strictly less than, x plus c. Modulus x plus c is strictly less than 1 plus 2 times mod c. So in this case, if we choose for delta equal to 1, so let me call it as delta 1. Right. So now and x minus c is less than delta, okay. Therefore, modulus, consider this thing, modulus of x square minus c square, and as it is comes out to be modulus x plus c into modulus x minus c. So what is it? Modulus x plus c, it is we have calculated just, it is 1 plus 2 times modulus of c, and modulus x minus c, it is less than delta. Right, less than delta 1. Therefore, for any given epsilon greater than 0, if we choose we have to find the value of delta equal to minimum of 1 and delta 1, then, and this value of delta 1 we should take, to have this quantity to be less than epsilon, we should take delta 1 to be epsilon upon, so that this quantity should get cancelled, 1 plus 2 times mod c, then modulus of x square minus c square is definitely less than delta. See the calculation here, if delta 1 is this thing, so denominator and numerator will get cancelled and epsilon will remain here, right? x is point of a and 0 less than mod x minus a less than delta. This delta is what? It is chosen to be minimum of 1 and delta 1. So we can say that it is the definition of limit is satisfied. So limit of x square when x approaches c is c square. So now we take some examples to find value of limit. So what is the next number example? Number 4. And the example is that limit x upon 1 plus x is equal to 1 half. And what value of delta we should choose so that it is equal to, the limit is equal to 1 half. So to show this limit is 1 half, so for epsilon greater than 0, consider, that means what we wish to show, how to find value of delta, so that for epsilon there, to find delta so that this difference x upon 1 plus x minus half is less than epsilon, and it should be true for any epsilon greater than 0 when 0 less than mod x minus 1 less than delta, right? That means x tends to 1, x is not equal to 1 and x should lies in the delta neighborhood of this point x equal to 1, right? So we consider this difference x upon 1 plus x minus half, and it is equal to, then make some calculation, it is 2x minus 1 minus x divided by 2 times 1 plus x. So simplify this, it is 2x, it is x minus 1, 2 times 1 plus x. So as x belongs to a deleted delta neighborhood of 0.1, so it is 1 plus something, so it is greater than 1, right? So it is a positive, so in the numerator it is x minus 1 upon 2 times 1 plus x, and definitely this thing will be less than or equal to, right? Because 1 upon 1 plus x will always less equal 1, right? And what we want, this, if this thing is less than delta, what we want this to be less than epsilon. So what delta should be? So delta should be 2 times epsilon. This should be less than delta. So actually it is half times delta, right? Less than, what I want this to be epsilon, this thing to be less than epsilon. So therefore if we choose delta to be epsilon, it is 2 times epsilon, okay, delta to be minimum of 1 and 2 times epsilon, then for epsilon greater than 0, this modulus of x upon 1 plus x minus half is less than epsilon when x tends to 1, 0 less than mod x minus 1 less than delta, and delta is what we have chosen here. So let us see the next example.